Hey everyone, and welcome! Today, we're going to dive into this incredible educational project that starts with just one tiny seed and, well, it blossoms into a massive lesson in biology, engineering, and even data science. We're going to see how a smart greenhouse isn't just growing plants, it's really growing the next generation of innovators.
So, here's the big question, right? How on earth can you teach something as complex as biology, coding, and engineering, all starting with a single seed? Well, the answer is pretty amazing. It's all about rethinking how we approach agriculture from the ground up, or, in this case, without any ground at all. Let's dig in.
Okay, here's our game plan. First, we're going to look at the science, this whole new way of growing. Then, we'll get our hands dirty and actually build the biosphere. After that, we get to the fun stuff, giving our greenhouse a brain and senses. Then we'll teach it to run itself, and finally, we'll see what we can learn from all the data it collects.
First up, Part 1, a new way to grow. You know, before students can start building anything, they have to wrap their heads around the core idea that makes this whole project even possible, and that's growing plants without any soil.
And that idea is called hydroponics.
Now, for a student, this is usually the first big whoa moment. The lesson? Plants don't actually need soil. What they need is what's in the soil. So if we just dissolve those nutrients into water and take them right to the roots, we can create a super efficient system for growing things.
And this is where the classroom lesson connects to the real world. Suddenly, students are comparing this new method to traditional farming, and they start talking about huge ideas like resource management, land use, and sustainability. They're learning how we could maybe tackle food production in cities or in places with terrible soil. It's a huge eye-opener.
And get this number, 90%. That's how much less water hydroponics uses. For a student, a statistic like this it's huge. It makes this abstract idea of sustainability something you can actually measure, and it shows them that the tech they're working with could have a massive impact on the world.
So, the project uses a basil seed, which is just a brilliant choice, and here's why. It grows fast. Students see results in just a few days, not weeks or months. This means they get to act like real scientists, keeping growth diaries, observing changes every day. It's instant feedback, and that keeps them totally hooked.
All right, so let's move on to the next phase. Part 2, building the biosphere. Now that the students get the why behind hydroponics, they get to tackle the how. This is where they become engineers, and their mission is to build the absolute perfect home for their little basil plant.
But, before you build anything, you need to know the goal. And the goal here is to optimize this one critical biological process, photosynthesis. All of a sudden, that word from their science textbook isn't just a term to memorize, it's a real engineering challenge. The whole greenhouse is designed to give the plant exactly what it needs to do this job perfectly. And here are the pieces they use to do it. For a student, putting this all together is a masterclass in systems thinking. They start to see how every single component, the frame, the pump, the lights, isn't just a random part. It's a crucial piece of a much larger puzzle. They're not just building a box. They're literally constructing a tiny living ecosystem.
Okay, now we get to the really cool part. Part 3, the electronic brain and senses. This is the moment the project goes from being just a greenhouse to a genuinely smart system.
So meet the microbit. This little thing is the brain of the entire operation. For a lot of students, this is a huge aha moment. You can think of it like a tiny programmable decision maker. It takes the mystery out of computing and shows them that, hey, they can write simple commands that control stuff in the real world.
And if the microbit is the brain, then all of these sensors, these are its senses. They let the greenhouse feel everything, from how wet the roots are to the air pressure. This is basically a hands-on introduction to the Internet of Things, or IoT. Each sensor becomes a mini lesson in how to measure one specific thing about the world around us.
So we've got a brain and we've got senses. What's next? Well, part 4 is all about putting the system on autopilot. This is where students get to put on their programmer hats and actually bring this whole thing to life with code.
And the core lesson here is something called the automation loop. Sense, decide, act. It's a really basic but powerful idea in robotics and computer science. Students program the system to constantly check its sensors, make a choice based on rules they wrote, and then do something about it. Sense, decide, act, over and over again. And this is what really makes coding click for them. They're not just staring at confusing lines of text on a screen. They're writing simple, powerful if-then statements that cause an immediate physical reaction. If the soil is dry, then the pump turns on. They actually see their code do something, and that is such a powerful way to learn.
And this right here, this is a brilliant next-level lesson in engineering, thinking about what might go wrong. Students learn to build in safety features, like a sensor that makes sure the water pump doesn't run when the tank is empty. It teaches them not just how to make something work, but how to make it smart and reliable.
All right, we're at the final phase now. And this is where the project levels up from a cool build into a true scientific instrument. Part 5. Learning from the data.
This is where the project literally connects to the rest of the world. The greenhouse starts sending all of its sensor data up to a cloud platform. Think of it like a public diary for the plant, where it logs how it's feeling every minute of the day. This teaches students a critical lesson. Their invention can be monitored from anywhere with internet. I mean, they can check on their plant from their phone. That's an amazing introduction to data science.
And with all this data and control, now the students can run actual experiments. They can start asking real scientific questions like, I wonder how different colors of light affect how my plant grows. They learn how to change just one variable, like the light color, and then watch what happens, analyzing the data their own system collected. This is the scientific method live and in action.
So when you pull back, what's the real takeaway for the students? It's seeing that these subjects, biology, engineering, coding, data science, they aren't separate things you learn from different books. They're all interconnected tools. They learn that to solve real-world problems, you have to use them all together. A biologist needs an engineer, who needs a programmer, who needs a data scientist.
And at the end of the day, a project like this is so much more than just an assignment. It's this powerful, tangible proof of how technology and science can team up to solve really big challenges, like figuring out how to create sustainable ways to feed ourselves in the future.
And that really just leaves us with one final thought. When you give students the tools to build, to code, and to analyze a living thing right there in their own classroom, you're not just teaching them science, you're teaching them how to be creative problem solvers. So the real question is, if this is what they can build today, what amazing problems are they going to solve tomorrow?